Hi folks, welcome back to Math with Captain Rod. The purpose of this video is to demonstrate how to find all extremas, relatives, and absolutes for a function. In this example, we're going to try to find all the relative and absolute extrema of the function y equals 4 minus x cubed over the interval -2 to 1. So, to find relative extreme values, relative mins or maxes, I'll put relative extrema, what we do is we look at the derivative of this thing, y prime. And as I look at this, its derivative is minus 3x squared. So this has a relative extrema at x equals 0, because if I set this equal to 0, solve for x, the solution is x equals 0. Now the million-dollar question here, is that a min, a max, or is it neither? And what tells us that is the second derivative. And just a little reminder, if the second derivative is positive, you have found a relative min. If the second derivative is negative, you found a relative max. If the second derivative is 0, it's neither. It's what's called an inflection point. All right, so if I differentiate this function again, we're going to get minus 6x. At x equals 0, the second derivative is 0. So what we have found is that at x equals 0, it's not a relative min or max, it's neither. The function does something like, let's say it's minus x cubed, so it's doing probably something like this. And it just isn't a relative extrema. Okay, so now the other type of extremas occur at the endpoints. F of -2 is going to be 4 minus a minus 2 cubed, which is going to be 4 plus 8, which is 12. F of 1 is 4 minus 1 cubed, which is 3. So this function has an absolute max at the point -2, 12. The absolute max is actually that value, the 12. Where it occurs is at x equals -2. And this function has an absolute min at the point 1, 3. There's your absolute minimum 3 on the interval given. So, kind of a boring example. I think what I'll do here is just pause this, write up another one, and just put it in the same video. Hi folks, I'm back. So let's see, I've written down another example. Again, we're going to try to find all relative extreme values for this function, open interval from plus infinity to minus infinity. So for starters, some things about this function. It's equal to x cubed times the quantity x squared minus 10x plus 25. And one thing I'd like to point out about that, when we multiply this out, this thing's going to be x to the 5th minus 10x to the 4th plus 25x. When x gets really, really large, this function is approximately x to the 5th for really large values. So what that tells me about the function is as x goes to the right infinitely far, this function is going to plus infinity. So I know that this function is basically going this way. And when x goes to minus infinity, x to the 5th also goes to minus infinity. So I know the function is kind of doing this in this way, in this direction. Now, in between here might be doing a bunch of stuff. I don't know. We're going to be kind of investigating the in between. But I can tell just because of this lead term x to the 5th, the function is going to plus infinity to the right, minus infinity to the left, so this function has no absolute maximum or absolute minimum. It probably will, however, have relative extreme values, relative mins and maxes, and we're going to look for those now in this example. So, don't need this anymore. Let me get rid of this just to get some more room. All right, so to find the relative extreme values, we're going to look at this thing's derivative, y prime, noticing that it has to be product ruled. Derivative of the first times the second plus the derivative of the second times the first. So that's applying the product rule differentiation. This thing's looking like a little bit of a bugger. So we got 3x squared times, okay, x minus 5 squared is x squared minus 10x plus 25 plus 2x minus 10, and that's times x cubed, so I'll do this here, fourth, and 10x cubed. I think I'll go ahead and multiply this out again. So this is going to be 3x to the fourth minus 30x cubed plus 75x squared plus 2x to the fourth minus 10x cubed. We can simplify this thing a little bit. Let's see, 3x to the fourth, 2x to the fourth is 6x to the fourth minus 30x cubed minus 10 more is minus 40x cubed plus 75x squared. Going to take a moment now. Did I miss anything? Got some helpers. Say what? 3 and 2 add to 5. Oh, yes, thank you. I was just making sure you're paying attention. Thanks. Now my arithmetic struggle today. I haven't drank this coffee yet that I went to go get. Okay, 5x to the 4th. Thank you very much. Got myself a coffee here to hopefully not make much of those. All right, so relative extreme values are going to occur where the first derivative is equal to 0. Now notice that we can factor an x squared out of every term. Then we're left with 5x squared minus 40x plus 75. X equals 0 is a solution to this. So one solution here is x equals 0, no doubt. Other solution is going to occur here, where 5x squared minus 40x plus 75 equals 0. Everything there is divisible by 5. Yeah, let's get rid of the 5. So we're going to have x squared minus 8x plus, what is that, 15? Yep. And looking at this, I'm betting this thing will probably factor. Factors of 15, 5 and 3. So this thing factors into x minus 5, x minus 3. So other numbers that are critical in this problem are x equals 5 and x equals 3. So these are all values where the function may have relative extrema. Now I'm going to take a moment and investigate whether those are relative mins, maxes, or zeros, or not extreme values, I'm sorry. And what tells you about that is the second derivative. So I can differentiate actually pretty much any line here. I'd say the one, probably the easiest one is going to be this one. So I'm going to focus on this line right there because y prime equals. We can differentiate that fairly easily. I'm going to go ahead and get rid of this stuff that we don't need. Okay, so y double prime is going to equal, differentiating this term by term, 20x to the third minus 120x squared plus 150 times x. And now I'm just going to check these values. Y double prime of 0 is equal to 0, right? 0's here, here, and here. Therefore, this thing right here tells us basically it's neither. It's not a relative min or max. Y double prime at x equals 5, I'll just take them in order, is going to be 20 times 5 cubed. Whoops. Yeah, that's right. Minus 120 times 5 squared plus 150 times 5. And I'm going to take a moment here and have one of my helpers just crunch a number for me. A little louder, I don't hear well. Positive 250 plus 250. So I'm going to go ahead and put that over here. So f double prime of 5 is, and really all we need here is the plus sign, to tell you the truth. We don't need the 250 for anything right now. It came out positive, which means that point is a relative minimum. And y double prime of 3 is going to equal 20 times 3 cubed minus 120 times 3 squared plus 150 times 3. And I'm going to wait a moment here for somebody to give me a value. plus 210. Okay, so y double prime of 3, this came out greater than 0. That means we got another relative minimum. So let me double check that just to be sure. Yeah, I guess that looks about right. Ooh, okay, we got to vote for negative 90 here. Let's get a third negative 90. Okay, so I'm going to go back and change that. We just had a little calculator oops here, and that's fine. Okay, so what we found now is that y double prime at 3 is negative. The 90 is not really important for this discussion. So it's less than 0, which makes that a relative maximum. Right? So this function we have found has no absolute min, no absolute max based on my beginning discussion here where the function is approximately x to the fifth for large values of x. That means it goes to plus infinity when x goes to plus infinity and minus infinity when x goes to minus infinity. But it does have extreme values at x equals 5 and x equals 3. I'm not going to bother calculating what those extreme values are. However, the 5 is actually pretty easy. Put a 5 here, you get 0 out, so the point 5, 0 is on the graph, and that was a relative, what did we decide that was? Second derivative, I can't remember now, but that second derivative was positive, right? So that was a relative minimum, I believe. And then we would put 3 in, and it's pretty easy here. We get 27 times, let's see, negative 2 squared. So 27 times 4, whatever that comes out to, is our relative maximum. So anyway, I hope this video helps demonstrate these concepts. Have a great day.